Welcome to qnawire.
For this problem, you're asked to calculate several things, several quantities given a non-constant force, a force that changes with time, and um, in athlete, that's about 65. So the problem is that you have a platform and you have an athlete that's at a certain height up here, and then their mass is 65 kilograms, and they're falling to this platform. And as they're falling, they exert a force with a certain with a certain function, and that force is not constant in time. So first, they ask you to calculate the impulse that this athlete exerts on from the platform, or the platform on the athlete. Either way, it's going to be the same size force. But you know that impulse is just a force times time. But since this t is not constant here, what you actually need to do is do an integral. So this impulse is now an integral of f as a function of with respect to time, because this time is not constant here. And when you do that for the equation that you now have to integrate that over the 9,200 t minus 11,500 t squared. And once you integrate this, and you're integrating, this is a definite integral because you're given the bounds. So this is from 0 to 0.8, which is the amount of time that this thing is acting on the, or the platform is acting on the athlete, or the athlete is acting on the platform. So if you do this integral, so this becomes t squared over 2 over here, and then this is t cubed over 3, and then you finish up the algebra here. What you find is that the impulse is actually something like 2,944 minus 1,962.6, which gives you a total impulse of around 981.4 Newton seconds. Again, because this is a force times the time. And then now this question is asking you to calculate what speed she reaches this platform with. So you know she's starting from a height of about 0.6 over here. So I like to use energy equations, but you can also use kinematics with this. But if you want to use energy equations, you can just say that the potential energy that the athlete has at the top should be equal to the kinetic energy that this person will have once they reach the bottom. So this equation will help you come up with an expression for the velocity, which is just the square root of 2 times g times h. Because once you remove that, and because it's common in both, you move to make v the subject, you come up with something like this. And once you have that, you find and put in the numbers. So 9.8, 0.6, you find that your v is about 3.43 meters per second. So now the next part is now asking you, what speed did she leave the platform with? So this is a little more involved, because now you have to kind of calculate certain things that are not essentially given in the problem. So you know that impulse causes a change in momentum, and this has to be the net impulse, because not only is the platform exerting a force on this girl, but the force of gravity is also exerting a force on this girl when she's on the platform. So now you have two forces. So essentially you want to calculate a net impulse in this case. So this is going to be the impulse that is given by this time-dependent force here. And then from that, to calculate the net, because this force would be pointing upwards, but the gravitational force is downwards. So you want to now remove the impulse provided by the gravitational force. So this would be m times g for the gravitational force, but since this is an impulse, this also has to be an impulse. So this is now has to be multiplied by the amount of time that this is being acted upon. So this is the constant force, therefore impulse is just the force times the time. This is time-dependent force that you got up here. So once you finish all of this, you find that you get the net impulse out here. So once you have that, you know that the change in momentum can be written as mv minus mu, where u is the initial velocity. So this is the final velocity, this is the initial velocity. But notice that as she's going back up here, the velocity is now negative. So this so the initial velocity that you had and the final velocity are in the opposite direction. So if I choose the final velocity to be positive, it means that this will be now a negative. And if this becomes a negative, then by this negative sign here, I can change that to a positive because they're in opposite direction. So you'll notice that your equation will now say that this is mv plus the mass times the initial velocity that we had, 3.43 here. So you put 3.43 in that equation. So now we know the full left-hand side here because it's just numbers, and we know the mass, so we can just go ahead and divide that over, and we know the initial velocity. So if you keep going with this problem, you find that once you do the net impulse, which is this whole side, over the mass minus 3.43 here, because so if this is the net impulse, you divide by the mass because it's common in both these expressions, and then you move that remainder term to the other side, it will show up as something like this. And then if you do this computation, you'll see that your final velocity here is going to be your final velocity is going to be 3.83 meters per second. And then the last part is, what height does she get to after this, or after moving with this velocity? So we can just then again use the same equation that I used in B here, but now I'm just reversing it. So for part D, I can just say, since I know that V is equal to 2gh, I can just say V squared over 2g should give me my height, because I just square both sides and then divide by 2g. And that, with all the numbers that you're given, with 3.83 for V, 9.8 for G, you will get 0.748 meters over here. And that's it.